again, everyone, and welcome to this video in the series on linear relationships in algebra. This one is going to focus on parallel and perpendicular lines. Now you can see in some of the notes there that there is some information about parallel lines in particular, and we're going to be talking about those, and we're going to be talking about perpendicular lines. So you can see a diagram there that we have some parallel lines and we have that rule, and then we have the non-parallel lines. So let's have a look. Our parallel lines. It's actually pretty simple in terms of the parallel lines. They will have the same gradient. So if you come across some equations and they all have the same gradient but different y-intercepts, those lines are going to be parallel to each other when you graph them, which I think is actually pretty cool. Now on the other hand, our perpendicular lines will actually have a meeting point at right angles. So in our diagram here, where these two cross forms a right angle. So that's essentially what the word perpendicular means. All right, so perpendicular lines cross at right angles to each other, right? So they're crossing at right angles, which means there's a special thing that's happening with their gradients. So essentially, we're turning the gradient upside down and making it negative. So we're finding what we call the negative reciprocal. Okay, so a perpendicular line, and we will be saying that word quite a lot, has a negative reciprocal. And that reciprocal, that word reciprocal, just basically means upside down. Okay, so how we write it, okay, is we have M2, so M2, so that's our second gradient, is negative 1 over M1. So that's what we're looking for. Okay, now another way that we can write it, all right, we have one more way we can write it, and that is M1 times M2 equals minus 1. So both of those things are the same. I like the idea of the M2 is equal to negative 1 over M1. I'll make that look like a bit more of a 1. Okay, now the equations of these lines can be found by finding the first gradient. So first find the gradient. So these can be found by finding the gradient. Okay, and then substituting in a point to find B. Alright, so we use the coordinates of a random point on the line. Make sure it's actually on the line though. Okay, and we're obviously using y equals mx plus b. Okay, that's essentially what we're talking about. So we can find out bits and pieces for the equation just like we have been before. We know that parallel lines will have the same gradient, so no matter what, they will always have the same gradient. And then if we want to have a perpendicular line, let's find the negative reciprocal. So let's turn it upside down and make it negative. Let's take a head first dive into our examples. Here we go. First of all, decide if the graph of each pair of rules will be parallel, whether they will be perpendicular, or neither. So let's look at our first one there. So first of all, let's look at our gradients. Let's look at our gradients. So here's our gradient. Here's our gradient. So those numbers are in fact the same. Make it a bit bigger. So these guys are the same. Gradients are equal. What that means is that we have parallel lines. They are, in fact, parallel. Second one there, we've got our gradients. Alright, here's one gradient. -3. Here's our next gradient. Is 1/3. So if you have a look there, -3 and 1/3. 1/3 is actually the negative reciprocal of -3. So we have -3. Right, so if we take our -3, we can say that's -3/1. All right, and then we find the negative reciprocal. Now, because there's already a negative in there, we get to take that negative away. And it's just 1/3. Okay, nice and easy there. So then here we have M2 is equal to -1/M1, or 1/3 is equal to the other way around. I should have done that a bit different. Okay, now if we wanted to work it out a little bit differently, we could use the M1 times M2 equals -1, which would be -3 times 1/3, which does in fact equal -1. So therefore, these lines are perpendicular. Okay, and they meet at right angles. Alrighty, let's keep smashing through. I've only got a couple of examples to go. I'm going to find the equation of this line given the following description. So this is that bit that I was telling you about finding the equations. A line passes through the point 0, 2 and is parallel to another line with the gradient 3. Alright, pretty simple. 0, 2, well, that's already a y-intercept. Because 0 for x means that we're going to be on the y-axis and it's at 2. We already have the gradient of 3. So our y equals mx plus b, well, that equals, or becomes 3x plus 2. Okay. 3x plus 2. Next one here, we've got a line passing through 0, -1 and is perpendicular with another line that has a gradient of -2. So still, y-intercept is right there. Okay, so we know that the plus b part is actually going to be -1. We have a gradient of -2, so we need to find the negative reciprocal. find the negative reciprocal. So we're going to start with our y equals mx plus b. And we already know, so we've got y equals mx plus, well, it's actually going to be minus 1. So that's the first part. We want to find the negative reciprocal. So we have minus 2, which can be minus 2 over 1. If we want to turn that upside down, we're going to have minus 1 over 2 times it by negative 1 to find our negative reciprocal. And it's just going to be 1 over 2. Okay, so that means that we've got a half. So we now have y equals a half x minus 1. And that's how we can do it. And you can do those notes if you really, really wanted to. Or you could just know those reciprocals and put them in, as long as you've written down where you've gotten them from and highlight it in the question. Alright, last examples here. Still finding equations of a line. Still finding equations of a line. We want one parallel to y equals minus 2x minus 7, but passes through 1, 9. So we don't want to have the minus 7 in there, so we don't need that bit, but we do need this. Okay, so I'm going to rewrite my equation as y equals minus 2x plus b, because we want to get a new y-intercept, and that y-intercept has to match up with a point, the line that goes through 1, 9. So now I can substitute in and I get 9 equals minus 2 times 1 plus b. The 9 is going to stay the same for now. Then we're going to have minus 2 plus b. Using all my algebra skills, I'm going to add a 2 to both sides this time. And that is going to get me to 11 equals b. So our y-intercept for our new equation is going to be 11. So my new equation is y equals minus 2x, because remember, we need the same gradient for a parallel line, plus 11. So these lines are going to be parallel to each other, just going through a different part of the y-axis. Last example. We want now a perpendicular line that is going through the point 3 minus 2, and it has to be perpendicular or at 90 degrees to y equals 1 over 4 x minus 1. So first thing I'm going to do is I'm going to find my negative reciprocal. So I'm going to find my negative reciprocal. So if I've got 1 over 4, alright, and I turn that upside down, I get 4 over 1. If I make it negative, I get minus 4 over 1, which just gives me minus 4. So that's my negative reciprocal. So I'm going to pop that into the equation instead of a quarter, and then do the same thing as I did before. So y equals minus 4x plus b. Now we've got those values for that coordinate for that point. Again, it doesn't necessarily have to go through minus 1 again. It may not, but we need to figure that out. So y is going to be minus 2 minus 4 times 3 plus b. Leave our minus 2 for now. Minus 4 times 3, well, that's going to be minus 12. And then we're going to go plus b. Now, simple algebra is going to add 12 to both sides. That's going to leave me with 10 equals b. So our new equation is going to have plus 10 as our y-intercept. So our new equation for this one is going to be y equals minus 4x plus 10. And that one is going to be at right angles to our other line. Okay, that's it for parallel and perpendicular lines for this video. Hopefully you've gotten something out of it and it has been a little bit helpful to you for these problems. Good luck with all your questions and thank you for watching.